In previous labs we've used Douglas bag method to measure oxygen consumption. Although Douglas bags are valid and reliable, we can use an online breath-by-breath gas analysis system in order to get live data of expired gases. This video shows the calibration and setup that's required to perform online gas analysis. The device we're using is a Cortex Metallizer 3B online gas analyzer. Before use, we need to calibrate the device in order to minimize errors and ensure accurate results. First, we have to calibrate the gas sensor to tell the Cortex two known quantities of oxygen and carbon dioxide. The sample line is placed in the ambient lab environment. The Cortex then compares the values it extracts against those that should be known from normal ambient oxygen and carbon dioxide. Once complete, the sample line is then placed in a bag that has another known quantity of gases. This has a higher percentage of CO2 and a lower percentage of oxygen, what we might expect following exercise. Next, we have to calibrate the flow sensor, which is what determines the volume of air that's being exhaled. This is made up of a few parts: a turbine housing, and also the turbine itself. The turbine is what spins in response to exhaled air flowing through it. The turbine goes inside the housing and is now ready for the next step of calibration. This horseshoe shape cable clips inside to the housing, and this is what detects how fast the turbine is turning inside, and thus can measure expired air volume. There's also a hole for the sample line to sit, and this is what samples the expired air during exercise. The calibration of the flow sensor is done by using a 3-litre syringe. Once attached, the syringe is plunged a minimum of 5 times in order to push the 3 litres through the device. The calibration determines how far this deviates from the 3 litres that's known. We can then confirm the settings of the calibration and proceed on to the next stage of the test preparation. There is some other equipment we need in order to run this test. Firstly, we have a face mask which is used to direct any expired gases into the flow and gas sensors. These come in different sizes in order to get a good seal between the participant's face and the mask. To attach this to the participant, we have a netting which is clipped into the mask, wraps around the participant's head and secures it in place. Lastly, if we want to measure heart rate during the test, we need an ECG heart rate monitor. Remember to wet the electrodes in order to improve conductivity. We can now get our participant ready to test. So firstly, we can direct the participant to place the heart rate monitor in the correct location. So this should be located just under the sternum. It's also important to ensure the heart rate monitor is the correct way round and that the electrodes have been wet before handing them to the participant. We can now attach the face mask. The easiest way to do this is to attach the top 2 straps and then place the netting over the top of the head. The researcher can now go round and attach the remaining clips and also tighten the Velcro straps. It's really important to get a good seal between the face mask and the skin surface. This is to prevent any leakage from occurring. We can get the participant to test the seal by placing their hand over the mask opening and breathing in and out. If no air escapes, we have a good seal. If it does, we may have to choose a different size mask and refit. We're now ready to put some participant demographics into the software. So we can do this by creating a new patient. We're then able to give our participant an ID if we're anonymizing the data. And we can also put in their first and last name if we're not. To generate normative values, we need to put the participant's sex, their date of birth, and also their height and weight. We then also need to select the mask size that we determined in the fit testing just previously. We can also put some other information in, such as their fitness level, and also if we've measured body fat or any existing medications that they might take. We're now ready to run the test, so we can select the participant. And then perform a last sensor adjustment which finalises the calibration.